Well, there I was preparing a new significant video I've got coming along when a friend phoned me and said, "Have you seen the ITV news tonight?" That was yesterday. It features one alarmist story after the other, straight from the off, go as it were. The first 10 or 15 minutes of the whole news programme devoted to climate alarmism from very ignorant, stupid people. I don't know how these people can call themselves journalists, because they're just reporters. They report what they're told. What they don't do is investigate. So I'm first of all going to show you a bit of this news, and then I'm going to take it apart for you.
The stark and brutal frontline of global warming. Antarctic ice is melting faster than ever before, collapsing before our eyes. Oh, God. We shouldn't be able to get this far south this late in polar winter. But what we're witnessing here, experts say, will have wide-ranging impacts across the world.
Well, first of all, I'll just report to you exactly where this filming is taking place. It's in the Antarctic Peninsula, as it's marked here. And if you look further, this is only 620 miles south of South America. And it is the bit of Antarctica that really sticks out and has some unique characteristics. This is how it's sort of officially described. The Antarctic Peninsula is a narrow strip extending from West Antarctica towards South America, and it experiences unique weather patterns due to its geographic position, oceanic influences, and climate dynamics. Here's what sets the weather apart, particularly in terms of unusual or odd phenomena. So it's odd. Well, I'll just mention it. There's many reasons why it's unique, but I'll just mention a few of them. So here in the peninsula, polar cyclones and storms, well, the peninsula's proximity to the Southern Ocean waters makes it prone to intense polar cyclones. These storms bring high winds up to 150 kilometers an hour and heavy precipitation, often in short, violent bursts. The interaction of cold Antarctic air with the warmer maritime air creates unpredictable weather shifts, like sudden blizzards followed by clear skies. Extreme temperature variability. The peninsula is one of the fastest warming regions on Earth, with average temperature rising nearly 3 degrees centigrade over the past 50 years, 5 times the global average. This leads to dramatic swings like record highs of 18.3 Celsius, February 2020, and lows below -20°C in winter. Such variability can produce sudden warm spells, causing unexpected ice melt or rain instead of snow, which is unusual for Antarctica. I'll repeat that last bit, which is unusual for Antarctica. And the reason is that it's on the boundary between two systems. So one system can swing in and change it, and the other system can swing back. So it's not the best place to look at what's happening in Antarctica. So I'll now take you back to the ITV propaganda.
To stand there and see it directly in front of us was incredible. It was really unexpected. It really hit home that we're seeing some rapid changes to the region, and we don't know what the consequences of that will be.
Martin and his team are the most southerly journalists in the world tonight, given special access on board the British research ship, the RRS Sir David Attenborough. Scientists there are shocked at what they're seeing, and even thousands of miles away, the dangers of climate change are already all too real.
Well, there we are. The first alarmist story in this news, we call it news, it's just propaganda, in this propaganda bit, is the Antarctic sea ice extent. It's terrible, it's low, it's going to have effects everywhere, and they go on to other things, I promise you. But we'll take sea ice extent as the first bit of absolute rubbish ITV gave us, and here are the facts. The oceans are about 71% of the Earth, and they hold about 1,000 times the amount of heat than the atmosphere does. So that's where the heat on Earth is. It's in the oceans. Now, the sunlight that is able to penetrate the oceans penetrates it down to 100 meters. So the shortwave radiation coming in from the sun goes through that ocean down to 100 meters and warms that top 100 meters, which is then circulated. It's been doing that for millennia. But if you look at the heating of the oceans from the atmosphere, well, that takes an awful long time because the heat only penetrates a couple of millimeters, if that. And therefore, it's quite insignificant compared to the heating from the sun. Of course, you wouldn't dream of warming your bath tonight by turning up the temperature of the air in the bathroom, would you? Because you know it would take an awful long time for that temperature in the air to be translated to warming that bath full of water. Now, in this simple image of a piece of ice or ice floating in water in the Antarctic, the air is very, very cold. It's like -10, -20, -50 degrees centigrade. So that is certainly not going to be melting the ice. It's going to keep it crisp and dry. What melts ice in the Arctic and the Antarctic is the temperature of the water. We know that water temperature is above freezing because it's water. Otherwise, it'd be frozen. And so it's the water temperature that melts ice in the main. That is the dominant factor, not the atmosphere. The last basic thing you need to know is the wind controls where the ice collects. So in this lake here, for example, the ice is collected at one end because the floating ice has been blown by the wind to one end. Really simple to understand, even though ITV don't seem to understand that. So armed with those little facts, let's go into the floating sea ice in the Antarctic. So here we have the Antarctic sea ice extent, the yearly average since 1979, when records began. That's when the satellites were able to observe it accurately. And as you can see, despite very big increases in CO2 since 1979, with a graph going up like this, the Arctic sea ice sort of varied. It was a slow gain. It kept on gaining, actually, slightly, until the 2012-2014 period, when it was a record sea ice extent. So how could that be? If all this time CO2 was growing, there was no relationship with CO2. And then it plummeted. It really plummeted and started to recover again. And then down and then up. And it's now coming up again. So what could have caused this? Well, believe it or not, there is one very well-established control of the extent of the sea ice, and it's called the AAO. I'll define it here. The AAO is the atmospheric Antarctic oscillation. It's also called the southern annular mode, SAM, and it's like a seesaw air pressure in the southern hemisphere. It describes how the atmosphere behaves around the Antarctic and nearby regions. Imagine a belt of strong winds circling Antarctica, kind of like a big atmospheric river. Sometimes this belt, which moves close to the Antarctic, called the positive phase, and sometimes it shifts rather further north towards Australia, the negative phase. The positive phase holds the sea ice out. Well, it pushes it out, and the negative phase holds it in. So let's see how those two relate, the AAO and the sea ice extent. The AAO has an index. Above 0, it's positive, and below 0, it's negative. And here it is on the vertical axis here, plotted against the sea ice extent. And you can see here a very clear relationship. In fact, it's highly correlated. So the one is affecting the other. And you can see in the positive phase, we have more sea ice extent. In the negative phase, we have less. But the alarmists may claim that the AAO is affected by the CO2, so we have to really dispense of that one. And here's the graph for that one. So this is a graph of the AAO, and that AAO is up the vertical axis, and the axis on the bottom is the CO2 concentration. And you can see it makes no difference at all what CO2 concentration you have. It doesn't relate in any way to the AAO. Totally no relationship whatsoever. So we know the winds there are not influenced by the CO2 concentration on Earth, because as that's grown, the AAO is still all over the place, has no relationship. Now, I have written a paper on this, actually. It's written in plain English that anyone can understand, not in technical jargon, and that's available in my Substack. The link to that is below this video. This is the conclusion of the paper. Antarctic sea ice is strongly tied to wind patterns, as shown by the tight link with AAO. Figure 1 shows this clear connection. From big ice years like 2014 to small ones like 2023, CO2, however, has no effect. Figure 2 shows winds and CO2s aren't linked, and Figure 3 shows sea ice and CO2s aren't either. These findings prove wind shapes Antarctica sea ice, while CO2 plays no role. Now I'm about to present you with a piece of absolutely useless information because all it records are single record type temperatures, which have no meaning in terms of climate, by the way, none at all. But I'm putting this as a matter of, how can I say, just interest. As recently as 2023, Concordia Station recorded one of the lowest temperatures for the current decade, a brutal minus 117.76 degrees. Similarly, at the Western Antarctica's Baird Station, a likely all-time low of almost minus 50 degrees was recorded as recently as 2023. These numbers may be surprising, but they are in tune with the unpredictability of climate and the nature in general. That's right, nature and climate are pretty unpredictable. And what I've tried to show you in this first section is how silly it was for that news story to be featuring this as if somehow mankind's influenced this. It hasn't. Mankind hasn't got any influence. There is no evidence for it whatsoever. So now that I've armed you with the knowledge about the sea ice extent in Antarctica, just look at what they are claiming so you yourself can actually understand just how much deception there is in this newscast.
Good evening from Dalgleish Bay. I am 67 degrees south, deep in the Antarctic Circle. The ship I'm on, the Sir David Attenborough, is full of cutting-edge scientific equipment and world-leading scientists. It's their job to try and understand what is happening to this continent and how climate change is impacting it. But many of those changes you can see clearly with your eyes. The very fact we are here at this time of year, in the middle of polar winter, tells a worrying story all of its own.
So the fact that sea ice has grown and grown since 1979, reaching a peak in 2014, in the exact opposite direction to the CO2 growth, by the way, that doesn't matter, because you can see in front of your eyes. And this seeing in front of your eyes, an instant time, if you like, in climate, is not climate. You have to look at the pattern. No idea of this. These are childish idiots.
Sunrise, 11 a.m. Our first glimpse of Antarctica. A frozen wilderness warming before our eyes. No British ship has sailed here at this time of year since Shackleton's Endurance.
Notice just what he said there. No British ship has sailed there since Shackleton's time. Well, what about other nations? They do exist. And secondly, we've got no proper records going back then of sea ice extent.
At Dalgleish Bay. Martin, why is it warming so quickly there?
Well, Gamal, that's exactly what scientists here are trying to establish. Where we are on the peninsula in Antarctica is warming 3 times faster than the rest of the continent.
3 times faster than the rest of the continent, so 3 times faster than the rest of the continent of Antarctica, which it always has done, in fact up to 5 times faster, because it's on the boundary. You can get hot one moment and cold the next. You know, a bit like sticking your head out the window on a freezing winter's day and putting a hairdryer over your hair. At times you'll feel cold and at times you'll feel hot. You're on the boundary, as it were. That's what it's like. There's nothing unusual about this. This is well established.
And so it's seen as the canary in the coal mine, the bellwether for what could happen elsewhere, where those really large ice sheets are. And what scientists are increasingly realizing is it's not so much the air temperature, but the ocean temperature, which is having a huge impact. To get into the bay we're in now, we sailed across what the ship's maps thought was land. It's not, it's a glacier which has receded. And this water behind us was until a few hours ago uncharted. We now know that the ice cliff behind me extends 175 meters below the surface of the water. So all that body of ice is being warmed by the ocean. That energy, that heat, has a huge impact. And it's as these glaciers melt and start to move into the ocean that we then start to get really big problems.
It is true that the oceans, the southern oceans, have warmed over the decades, especially since about 1950-ish, when we began to take some records. But these days we got better records with the Argo boys. And yes, it has warmed, although the amount of sampling is very small because of such rough conditions down there in the southern oceans. So there has been warming, and he's correct. It's the water temperature that melts the ice, but they're not in a typical Antarctic place. Nevertheless, Western Antarctica has been warming much faster than Eastern Antarctica. Eastern Antarctica has hardly warmed at all, and in fact there's been some cooling. So it's not hugely significant, and there's no great news here. What they're doing is taking the sea ice example, which is the sudden drop, and making the most of it.
Now we glide through almost open water. We shouldn't be able to make this journey. The very fact we can, in mid-polar winter, is a warning shot across the bows from Mother Nature. Gee, aren't you going to be cold?
Just a little bit.
Bosun Dave has been making this journey for 39 years. Never this late in the winter.
And as per our graph, of course, that is true, because this is the lowest on record. Yeah, but this is after all those years of climbing to 2014 when CO2 was rising. So it's nothing to do with CO2, but it is true that it has gone further than it has in the last 39 years. No problem about that at all.
What do you think it says about how much this place is changing, the fact we're making this journey in June?
In global warming kind of thing, it's pretty unusual. That's what I mean. I wouldn't believe we'd be down here this time of year.
We sail through a sheltered stretch called the Gullet, unencumbered by the sea ice which would have made this route to Rothera almost impossible in the past. The bay next to the British Antarctic Survey Station used to be frozen by now. Compared to 30 years ago, there is now 1.5 million square kilometres less sea ice than there used to be.
So there we are. You see they're misusing the statistics there. He's gone back to 1995, and there it is there. And yes, there is far less. But what he forgets is that in 2014, look what we had. It was an even bigger drop. You see, what they use is they forget the inconvenient facts of this growing sea ice extent since 1979, and then the sudden drop. There are factors here we truly don't understand, and there's a lot of study needs to be done. What we do know is it's not related to CO2.
At this time of the year, that equates to an area 6 times the size of the UK.
The retreating sea ice is linked to the warming of the ocean. And that's something that we know us humans are doing. So there's a direct signal there of our activity. The implications of this are climatic in that it affects how reflective the surface of the planet is. So the planet's now absorbing more heat from the sun than it used to.
So using that logic, up to 2014, we kept on reflecting more heat back, and the heat energy from the sun penetrating the water was less. You can't have it both ways.
It also removes a protective barrier from around Antarctica and can actually contribute to the destabilization of the ice sheets.
That's what's happened to the Sheldon Glacier. Without ice acting like a cork, it's collapsing into the sea.
So what you've just seen is the collapse in that glacier between 1950 and 2008. Well, as it happens, there's also a record of that glacier in 2012 with a photograph from the British Antarctic Survey. Not from above, unfortunately, but there's a report on it, and here's what it says. Just 4 years later, of course. View of the Sheldon Glacier with Mount Barr in the background, seen from Ryder Bay near Rothera Research Station, Adelaide Island, Antarctica. A new NASA British Antarctic Survey study examines why Antarctica sea ice cover has increased under the effects of climate change over the past 2 decades. So now they're blaming the increase in sea ice cover, which was building and building then, of course, to what? To climate change. So you have it both ways. You can have it when it's going down to climate change, man-made, and you can have it when it's coming up to climate change. Makes no difference. Whichever way you have it, you're going to blame humans for this. And just to nail that point, the first direct evidence that marked changes to the Antarctic sea ice drift have occurred over the last 20 years in response to changing winds, I agree, is published this week in the Journal of Nature Geoscience scientists from NERC's British Antarctic Survey and NASA's Jet Propulsion Laboratory, Pasadena, California, and explains why, unlike the dramatic losses reported in the Arctic, the Antarctic sea ice cover has increased under the effects of climate change. So there we are, big reports until the facts change, and then they swap the story but keep the same narrative. Wow.
Back on board, Mike and his colleague Rhiannon revisit a different glacier. They saw carve 3 million tonnes of ice in the summer 6 years ago. Unbelievably, whilst filming it in the dead of night, God, it happens again.
That's detached from underneath.
No one expected it to do this in front of their eyes in the middle of winter.
Well, for this, I've taken the recent study, 2025 from Wang, which reports a mass gain of 107.79 gigatons a year. That's plus or minus 74.9 roughly, but it's a gain, and that's for the period 2021 to 2023. It is a difficult thing to assess this. Data for 2024 and 25 is less certain, with indications that the mass gain may have stopped after 23, but there's no proof. So basically, there's no evidence that Antarctica is losing ice at the moment. And of course, if you have more precipitation in Antarctica, it comes in the form of snow in the main, and that accumulates it. So just a recent report sort of not backing up the idea that we're losing ice at an alarming rate. And by the way, glaciers coming from land calving are normally a good sign, like in Greenland, because then what's happening is the snow's piling up in Greenland high and forcing the glaciers, which are just slow-moving ice rivers, into the sea. And the fact that glaciers reach the sea and calve is a good sign, not a bad sign.
The theory is ice collapse on this scale causes underwater tsunamis.
So I'm going to switch this one on.
The team are monitoring water samples to understand how those waves release heat, carbon and nutrients into the environment, not to mention huge amounts of fresh water. Latest modelling shows, even in the unlikely case we can cap global warming to the 1.5 degree target, melting polar ice will push sea levels up by 1 centimetre a year come the end of the century, a rate fast enough to tangibly affect the futures of children alive today.
The problem for all this alarmism is this hasn't happened so far, so they'll always move the prediction of doom and gloom to the future. And in this case, even scaring children, as it were, this is going to affect your life terribly, etc. You've got to control CO2 to the magical 1.5 degrees centigrade. There's a direct control knob. CO2 temperature is absurd, totally absurd. And this is just pure alarmism. Now look, I could go on taking that apart, but they raised a number of subjects in this broadcast, and I haven't got time to deal with everyone in this video. I'm going to do follow-up. But I am going to deal with just 2 more things that they raised, and here they are.
It almost sounded like a freight train came, and it took the roof.
Rachel is in the Bahamas, where increasingly powerful storms combine with rising oceans to threaten the island's very existence.
When you look at the predictions of what's likely to happen here over the next 20, 30 years, do you think it will be livable for you?
I'm willing to stay till the end, but at the same time, I'm not going to stay too long until it kills me.
Oh dear, oh dear, oh dear, the old chestnut, hurricanes, tropical storms. Now, even the IPCC themselves state, Table 1212, that there is no human influence yet been found in increasing tropical storms. And in fact, they haven't increased. If anything, a slight decrease. But, call it about the same. And the far worse storms, were more than 100 years ago, by the way, as is normal. The worst weather was pre-1900. But I'll just deal with this because I've dealt with it so many times. I'll deal with it by showing you a few graphs just to show how ridiculous this claim is. And please note what they're doing here. They're saying the next 20 to 30 years. Well, this lady has survived the last 20 or 30 years, hasn't she? And it hasn't actually got worse in that time. It hasn't been worse than the previous times. The truth is, hurricanes have always hit there. That's the truth. And we only really started properly measuring them in the satellite age because the satellites pick up every one. But in the past, only the landfall ones were really measured when it hits land, because a lot of them just sweep in from Africa, curl around, and actually never touch land and go off to give the UK here some bad weather. So let me just cover that in a few graphs, and then we'll move on to the second absurd claim in that tiny clip about rising sea level, which I've also covered so many times, and simply not true. And by the way, I've sailed almost every single island and cay in the Bahamas. Okay, so here we have the hurricane graph. Now the blue line is the amount of energy, it's called the ACE index, in the hurricanes for a particular year. So you might have a category 2, a category 4, 1, 4, 1, 1, etc. You add it all together, the energy, and that's how much hurricane energy that year. It's by far the best measure of hurricanes. And we plot that on the blue line. And then what's the orange line? Well, the orange line is the Atlantic multi-decadal oscillation. What's that? Well, from the equator up, the Atlantic warms up in a cycle and cools in a cycle. It oscillates, and it oscillates by about half a degree or more. And that happens on a 60 to 80 year full cycle. So for about 35 years or so, it's warm. And for 35 years, it's cool. And when you plot that, AMO it's called, against the hurricanes, you can see when the water's warm, you get bigger hurricane energy. When the water's cool, you get less. Pretty common sense, because hurricanes take all the energy from the water. The warmer the water, the bigger the hurricane, the more energy is in it. And so what this shows is that around about 2005, when the AMO peaked, we had the worst hurricanes. It's totally rational. What we've not got is increasing hurricanes. Now, if you look at the history of hurricanes, say for the USA, I'm going to just read out the top 16 hurricanes very quickly in the next chart. Well, the worst one on record was 8,000 dead, was famous. The Great Galveston Hurricane, 1900, and the next one, 1928, the next one, 2005, which coincides with our previous chart. That was a big one, Katrina, in 2005, when the ocean was its warmest on the multi-decadal oscillation. Right, the next one, 1893, the next one, 1893, another one, and the next one, 1881, the next one, 1957, the next one, 1935, 1856, 1926, 1909, 1919, 1915, 1915 again, 1969 and 1938. So I don't think the lady there in the Bahamas has too much to worry about in the next 20, 30 years. Because actually, the AMO is entering a cooling phase, which is going to see a serious drop in the hurricane activity. You see, all I'm doing is providing data and evidence. It's all evidence-based. And where we've got a rational explanation, such as the AMO there, we use the rational explanation. There's nothing new in this. There's nothing big or clever by me in this. It's straightforward stuff. It's just that the idiots in ITV don't seem to understand it. They'd rather scare everybody and carry on with propaganda, because the mainstream media generally, the BBC's even worse, the mainstream media generally are full of propaganda, not news, propaganda. So let's move on now to what would also raise there, rising sea levels, which I've also covered many, many times. And of course, all the islands, the Vanuatu, the most exposed island in the world for rising sea levels, the land's grown. The lands have grown in the Maldives. The land's up to 8% in many cases, now measured by satellite. That doesn't stop them asking for money, by the way, for, proposed that may be sinking. So where this lady's being interviewed in the Bahamas, I've been there. And I can tell you for certain that they've lost no land. And where's the evidence? Well, I've got data. And there it is from the World Bank. They've monitored the land area for the Bahamas. And here's the graph. So what this graph shows is nothing really. It shows that the land area has remained the same for almost 60 years. There's been no change in it. That doesn't mean to say that some little bays haven't eroded away. I mean, the rock structure there does mean the sea erodes it. Other places gain, other places lose. Overall, there's no land use loss at all. We'll now play a further section of the news just so you can see how they really escalate the panic here. And you're going to see all the world leaders meeting at the Oceans Conference, the big Oceans Conference, as if they can do something about it, because they can't do anything about the hurricanes. They can't do anything about the floating sea ice, because that's down to the wind, as I've explained. But they all pretend they can, and they all meet and spend your money. Just watch this.
Home and abroad, the evidence is stark. The world at. Raggi is a Nice where leaders gather without the United States to try and stop a climate catastrophe.
There are many delegations coming and leaving and holding plenary sessions and discussions on this first day of the UN Oceans Conference. And behind me is the Chinese delegation.
And there, in one go, we have the hypocrisy of this situation. China, the largest CO2 emitters in the world, that delegation takes part, they're all respected, no one criticises them, and they're the biggest emitters of CO2 in the world. Well, in my world, they're doing us a favour, actually, because we need more CO2. But in their world, they don't criticise. If they were serious, they would. This is propaganda at its worst, and it's typical of our mainstream media. And with that little lesson, I will leave you on this video. Thank you for watching.